All right, guys, so in 6-2, we're going to be combining functions. And I'm just going to work one example here. We're going to do f plus g of x, f minus g of x, f times g of x, and f divided by g of x. F divided by g of x. Now, on each of these, not only do we have to do the mathematical operations, but we also have to state the domain of the new combined function that we have. So the first thing we're going to have to do is you're going to be given two functions. You want to define the domain of each individual function. In this case, f of x equals x squared plus 6. Well, my domain in set builder, we're going to say it's a set of all x's such that x is an element of the real numbers. If I want to do it in interval notation, that means it's going to be from negative infinity to infinity. And of course, you use the curved brackets with infinity because you never touch them. My g of x, though, is a square root. We're going to do a square root of 1 minus x. Well, what we're going to have to do, we're going to take what's underneath the square root, I'm sorry about that, the 1 minus x, and it has to be greater than or equal to 0, because we can't have anything less than 0 underneath the square root unless we want imaginary numbers. So to figure my domain out, I have to do 1 minus x has to be greater than or equal to 0. And then we're just going to solve for x. We're going to subtract 1 from both sides, so we have negative x is greater than or equal to negative 1. We're going to divide both sides by negative 1, and you must remember, when you have an inequality, when you divide or multiply by a negative number, you switch your inequality. Therefore, we get x is less than or equal to 1. So my domain for this function in set builder is going to be the set of all x's such that x is an element of the real numbers and x has to be less than or equal to 1. If we want to do this in interval notation, this really means it's going to be from negative infinity up to 1, and we're going to use the square bracket because of the equal to sign. It's less than or equal to, so you're going to use that square bracket. So now we have our domains of both functions. So let's look at my first example of f plus g of x. What this really means is that you're going to do f of x plus g of x. So we want to substitute those in. My f of x is x squared plus 6. Then we're going to do plus my g of x, which is the square root of 1 minus x. Well, we can't really add these. I can ignore the parentheses, and we're going to have x squared plus 6 plus the square root of 1 minus x. To figure the domain out, you're going to look at the original domains. We have an original domain that was not restricted at all. It's from negative infinity to infinity, or all the real numbers. However, the square root is restricted. So you're going to take your most restricted domain in this case, and that'll be your domain when we're adding, subtracting, as well as multiplying. So my domain for this one is going to be the same as if it was just the square root. So we're going to have, it's going to be the set of all x's such that x is an element of the real numbers and x is less than or equal to 1. Or it's going to be from negative infinity to 1 in our square bracket. So that's how we're going to do f plus g, and that's how you find the domain. You're going to look at the most restricted domain of the two. Now let's do f minus g. F minus g of x is really f of x minus g of x. Plug them in. We're going to have x squared plus 6. Make sure you use your parentheses, because right here with the minus, you got to make sure that minus goes to everything within the g of x. So we have the square root of 1 minus x. Now there are times you don't have the square root. You have to distribute the negative sign. So be careful and not drop a sign. I don't really need the parentheses here, so I end up with x squared plus 6 minus the square root of 1 minus x. And my domain is the same thing as the f plus g of x. You're taking the most restricted domain of the two functions, which is going to be x, the set of all x's such that x is an element of the real numbers, and x is less than or equal to 1. Or negative infinity to 1, and of course we have the square bracket. All right, my next one that we're going to do, we are going to do f times g of x. And of course this just means f of x times g of x. So we put them in. We're going to do x squared plus 6 times the square root of 1 minus x. This whole thing right here, this whole thing is a term, so you can distribute it in. So we end up getting x squared times the square root of 1 minus x plus 6, the square root of 1 minus x. And your domain is exactly the same as when you add and subtract. So my domain is going to be the set of all x's such that x is an element of the real numbers and x has to be less than or equal to 1. Or you can say it's from negative infinity to 1 square bracket. Now the last one we're going to do is going to be f divided by g of x. What this means is you're going to take your f of x, you're going to divide it by your g of x. Well, my f of x is my x squared plus 6, and we're going to divide it by the square root of 1 minus x. Now this, I don't like having the square roots in the bottom, so we need to multiply it by that fancy 1. So this becomes the square root of 1 minus x, the square root of 1 minus x. Once you multiply these out, you end up getting x squared times the square root of 1 minus x plus 6, the square root of 1 minus x, all over 1 minus x. Here's where your domain changes, because you can never divide by 0. So we're going to take our denominator and we're going to set it equal to 0 and see what new restriction is on our previous domains. So when we do 1 minus x, it cannot equal 0. Solve. We have negative x cannot equal negative 1, therefore x cannot equal 1. Because we know 1 minus 1 will give us 0. Well, if we look at our previous domain, our x could be really anything as long as it was less than or equal to 0. So we have to modify that domain a little bit. And my new domain is now going to be, it's the set of all x's such that x is an element of the real numbers and x has to be less than 1. This time we can't have the equal to, because if we had the equal to 1, we would have 0 in the denominator, and we can't do that. In interval notation, the way to write that would be from negative infinity to 1, but now it's a curved bracket because you're going to go right up to 1 but never touch it, whereas the square bracket means you actually touch it.